Hi everyone, and welcome to this new class in engine propulsion and specifically the design of the inlets. So inlets, basically what they are is a way for the flow, for the airflow, for a specific air given a certain velocity of the aircraft to actually enter to the engine, through this device, so through this inlet, right? The inlet itself would not produce any work to the air, which means, this is a physical definition, which just means that there will be no change in pressure due to the inlet. It will just allow the flow to get from the inside to the inside of the engine. Now, the flow will smoothly enter the inlet, at a specific temperature, which is actually related to the velocity of the aircraft, meaning that the temperature at which the flow will enter is not the same temperature of the ambient, is not the same temperature of the exterior, but rather a temperature which is increased due to the velocity of the aircraft itself. So we will have a small increase of the temperature. Now, in general terms, this would be a gas turbine, which you can see is just, in this case it's a turbo fan. You can see the fan, over here. And you can also note that the inlet is just subsonic in this case, And most of the aircraft, commercial aircraft, will actually have this kind of inlet, because this kind of inlet is optimal for subsonic regimes. And this means flowing at a velocity lower than the speed of sound. Also, you have inlets which are different for supersonic aircraft. Now, this is interesting because it's a bit different, and the idea for supersonic aircraft is that we need to provide some kind of inlet which allows shock waves, which appear due to the fact that our aircraft is going higher than the velocity of speed. So shock waves, have to be absorbed in some way or another before entering the engine, because if the shock waves enter the engine themselves, then they can easily break some of the elements of the engine. So inlets in case of supersonic aircraft are more important, are more relevant, because they have to comply with this mission of actually kind of reducing the energy of the shock wave due to the supersonic flight. So we have different ways of doing this. There's in this aircraft, for instance, you have this kind of geometry, which is just like this kind of, it's known as internal compression. What it does is the shock wave will actually enter at a certain angle, this angle of the shock wave is usually given due to the velocity of the aircraft, and what it will do is actually absorb the energy of the shock wave and convert it into some kind of normal shock, which will behave dynamically. It will behave as a normal flow. So the idea is that we are able to actually provide some kind of way to absorbing the amount of energy of the shock wave, and reducing it for it to be introduced to the engine and correctly converted into additional energy for thrust purposes, right? So that's why we need the engine. So this is a way to do it with an internal compression, like in this case, in this aircraft. Other ways to doing it is just by, and this is usually the case for very high velocity aircraft, so very supersonic or even hypersonic. What we do is we actually put like these cones, over here. You can see that these cones, what they do is they break the shock wave, and they make it break in such a way that the shock wave is actually disturbed and separated and will not enter directly to the inlet, which would be this part over here. This is a schematic view of how this would work. The idea is that because we are flying at very high velocities, the shock wave will actually have a very high angle, okay? And due to this angle, we need something to be disturbing the shock wave in order for it to disappear, or at least not appear as strongly, okay, in the inlet itself. So the inlet in this case would be this zone over here, the surrounding of the cone, okay, and the inside of the engine, right? So in a similar way to the case before, what we do is we reduce the energy of the shock wave in order to transform it into kind of a normal shock, which is just a perpendicular flow, right? And this perpendicular flow will then be able to, or will be transformed into additional energy, which is what we need from the thrusters, from the engines, okay? So this is some examples also that I wanted to include. You can see here the difference between subsonic, okay? So velocity is lower than the speed of sound, which is basically all of the commercial aircraft, apart from the Concorde, okay? And you can see the distinguishable turbofans in this case, right? And here you can see that the inlet is, as we saw before, an internal compression one, and it will provide a way to absorb the shock wave that will appear due to supersonic flight. Okay, so we can move to the next topic.